All right, should we start? Welcome everybody.
Sounds great.
Yeah, I'm going to start because we have a really tight schedule. So welcome everyone. This is the air quality cluster session, and we are just going to go right ahead. I just quickly want to say, the goals of today's session are really to get data providers and data consumers together and talking to each other so that the data providers know what the consumers need and the consumers understand what the providers are providing. So to get us launched on that, towards that objective, we've got some really great speakers, some people that are using air quality data, and we've also got some people that are providing air quality data, and they're going to tell us what they need or what they're doing and what they've got and that sort of thing. When we finish with our presentations, we're going to sort of have a little bit of discussion, come up with some takeaways. At our air quality cluster meeting, we agreed that we wanted to do that in breakout groups. Erin, are we able to do that, or was that something I needed to set up ahead of time?
We are able to do that.
Okay. And you'll be assigned randomly to a breakout group, and you'll just go into that room. You'll get a little notification saying what room that should go into this room or something. And then you'll go in there and you'll chat with people about, what you learned. And then we'll come back together as a large group and report out on, what our takeaways from this session were. And with that, I'm going to stop talking, and Jean, I think you're up first. And so, sorry, yes, our first speaker is Jean Holmes with the City of Los Angeles.
Great, thanks, Beth. I appreciate it. And good morning to everybody. Glad to be here and glad to be part of the group. And I'm joined by my co-presenter and co-investigator, Mohammed Purmahamian from Cal State LA. So we'll be sharing the time and keeping it succinct. So I'll turn off the video and just talk to the slides to make it a little bit easier. So kind of to what Beth was saying, we're one of those people that both consume and provide air quality data. We are very small on the provisioning portion, but a lot of what we do is deploy sensors around the 500 square miles of the city of Los Angeles. Those sensors are historically not integrated well. They're just really more like on a pilot or specific effort. And part of this project is really that idea of how do we federate very disparate sensors in space and on the ground in a way that lets us normalize and apply machine learning to those to create predictive models. So the next slide. You have control, Beth.
No, Mike does.
Oh, Mike. Oh, well, then I'm really lost. So the goal here is to really working with a lot of the people who are already providers, and OpenAQ is one of our primary partners, and Krista, who's still currently with OpenAQ, is the other co-investigator. We are trying to create an actionable global air quality index that's really focused on actions that cities can take and local municipalities in order to improve our ability to create and work with policies that have a better outcome for health and air quality. So this is, I think, a group that has often been disconnected from the Earth Science Information groups, and I think this is a nice opportunity. So I serve, just as a reminder, I report directly to Mayor Eric Garcetti, who runs the C40 cities across the globe. And so these cities are all focused on air quality and other environmental and climate change issues, which gives us a pretty good leverage point to be able to take the work that we're doing and really kind of robustly work with other cities and be able to make these models accessible to them. We're also working as an early adopter to the Maya mission. So in addition to what we're learning, we're feeding that into Maya in some of the ways in which they're looking at how they collect and manage and organize their data, as well as just being part of that community. And what we've really seen in the past is that that there are lots of pilots, but there's less of sort of the city to city collaboration that augments the work and kind of collaboratively learns from the work that goes on in the earth science community. And so we're really working on ensuring that the work we do is done in a way to start to make that collaboration easier and to lift up other work that would also be able to do that. Maya is MAIA. Next slide. So the solution that we've been doing is really to create this model for cities. The model is one which is gathering satellite data. So we're starting with Sentinel and a few other NASA missions with MODIS and Terra. And then we're taking data that we're gathering from a variety of ground sensors. There is a large group in Southern California called the South Coast Air Quality Management District. And we've been using their sensor data for the initial pilot. We just started this project a month ago. And then we're also using data gathered from our Internet of Things deployment on streetlights and trash trucks and at our libraries. And at the end, we'll talk a little bit about some of the partners we have, including Safecast and others, for some of our ground data sensors and our citizen science work. And then we're really working on the main focus of the research is how we can apply machine learning to these large data sets that are coming from different data sources to predict the air quality and relate that back to local interventions and improve decision-making for governments. And with the next slide, I will turn it over to Mohammed.
Thanks, Jean, and good morning, everyone. I hope you're all healthy and safe. Our predictive model is in the form of a pipeline the main part of that, of course, is the machine learning and deep learning algorithm, the orange box, but it also includes a set of algorithm for pre-processing the data, removing the outliers, missing value imputation, feature extraction and selection, and so on. And we applied various machine learning algorithms for processing different types of data. And after prediction, of course, the last step is to visualize the results and reporting the results. Next slide, please. In this type of data, so air pollution, of course, there are different types of correlation. We have both temporal correlation and spatial correlation in the data. There are a group of algorithms that we usually use when we have a temporal pattern in the data. The most well-known set of algorithms are recurrent neural networks. And of course, there are other groups of algorithms that we use when there is a spatial correlation in the data, for example, in images. The family of convolutional neural networks are the most popular one. In this project, of course, in air pollution data, we have both temporal and spatial data, and we want to take advantage of that. We use convolutional RNN or convolutional LSTM algorithms that take advantage of both spatial and temporal data. In other words, we treat the data like a video, that each pixel, in each frame, each pixel is correlated to the other pixels, and at the same time, each frame is correlated to previous and next frame. Next slide, please. So this is a very simple model, a very early model that we developed based on sensor-based data, ground-based sensors for predicting PM 2.5 using 8 sensors in the Los Angeles area. So this circle shows the location of the sensors, and we collected the data for 1 year on hourly basis. So the data, the total data was 1 year. We used 10 months of that for training the machine learning model and 2 months for testing. Next slide, please. So as you see here, this data is very dense in terms of time, because the data is on hourly basis for 1 year. So it's pretty much dense in terms of time, but it's sparse in terms of location. So we have only 8 sensors in the whole Los Angeles area, and a lot of cells, for a lot of these cells in this grid on the right-hand side, we don't have any value. So to train our machine learning model, we did a 2D interpolation to estimate the value of other cells that we don't have an actual sensors on them. And we used the 5 closest sensors based on their distance to estimate the value for other cells that there's no sensors there. So this was just an estimation to train our machine learning model, to build the training data for our machine learning model. Next slide, please. After training the machine learning algorithm, so this is the results. So in this case, we used a 40 by 40 grid for the Los Angeles area. The left picture is our prediction for next 10 hours based on the previous 10 hours of the PM 2.5 value. And the right picture is the actual value measured by the sensors. So as you see, the prediction is pretty much it's pretty much an accurate prediction for the actual value, which is on the right. In another test, so next slide, please. In another test, in another predictive model, we developed a system to predict NO2, this time based on satellite images. So satellite images are different. It's the other way. They are actually very dense in terms of location because they're actual images and we have value for each pixel. But they are sparse in terms of time because the data that we used was on daily basis, not on hourly basis. So in this case, again, we used the past 10 frames, which means the past 10 days of data to predict next 10 days. And this is our results. So the left-hand side is, of course, the prediction results from our machine learning model for predicting NO2 in the in Los Angeles area, and the right-hand side is the ground truth. So the brighter means the higher value of NO. So can you go back to the previous slide again? I forgot. So this one is again the brighter color means the higher value for PM 2.5. Okay, next slide. The next one. So yeah, Jean, please take over.
Sure. So as I said, we're just building on this model. We were planned to start earlier this year, but many of us at the city are involved with COVID and other issues. And so we graciously took a start date of this just in May. So I guess it's been 2 months now that we've been working. We're going to continue to evolve this model and the algorithms and the validation. We're pulling in now some of our additional local data sensors and be able to understand. And we're working also with some of the healthcare companies. So Anthem Blue Cross and Kaiser Permanente and the Southern California Asthma Association to understand some of the issues of making data, satellite data, more accessible to even broader swaths of the population. There are gaps in the coverage, as Mohammed inferred. Some of those are covered as we'll start to bring in other sensors that are already deployed, but we're working with Safecast and a startup company here in Los Angeles called Smart Air LA and Purple Air that will be deploying more sensors. And we're going to be taking a citizen science approach to a fair number of those as well. And layering a little bit of environmental justice on that. So we're going to particularly look at some of our underserved communities and places where there's more health impact. There's also been developments, even as we were beginning the project because of COVID, both in the improvement we had temporarily in air quality, but then also the comorbidity of COVID related to air quality. And so we may end up with some interesting results as we start to kind of unravel the issues around communities where there's heavy air pollution, like around our port and the airport, and then the effect of COVID there and the problem that those two have together. We are working with C40 cities, which Mayor Garcetti leads. I'm an advisor to the UN Sustainable Development Solutions Network, and we'll be presenting these results there as well as a variety of other places. And we're developing a global network of sister cities. So London is the first one, but we're also in discussions with Freetown, Sierra Leone, and a variety of others in Delhi as we start to move forward. And next slide. So we're open to collaboration. We're very interested in collaborators. If you have data, if you want to have a place to pilot anything, let me just open up the 500 square miles of the city of Los Angeles as a place-based area you might want to pilot. If any of the data sources that we find, we will make accessible through OpenAQ so that other people can have access to some of those even hyperlocal data set sources. And then we'll be working through GitHub and a variety of other ways to make sure that everything's open and transparent and easily accessible. I think the last slide just speaks to some of our partners, which we've been very grateful for. Lots of people have stepped forward to help and share. And we are grateful for the opportunity to work with an AIST grant. And thanks to Mike and Beth and Ian and the whole gang there, and Jacqueline. So thanks, and we're open to questions through the chat. I can't remember the name of the tool you're using.
Slido. Yeah, if you have
Slido.
specific questions, Slido, but people also, you can totally put them in the chat. If I see them, I'll grab them and put them in Slido just so we capture them, but using the chat is just fine.
Sorry.
Do you want to have questions now?
Well, we've got 5 minutes. I think we could have a few questions. Let's see.
Okay.
Do we have any?
I'll turn on my my camera. Hi, this is Dave Jones. I'm really interested in seeing how we might be able to, or whether you have done this already. We have funding from NOAA's JPSS program, and we're funded under 2 initiatives. One is called the Fire and Smoke Initiative, and the other is called the River Ice and Flooding Initiative. And so we're testing out the ability to access and share NOAA data, specifically related to smoke and where smoke is going. And so we're able to display some of the JPSS data at the same time we can access EPA's Air Now data sets. And it would be really cool to integrate this data to see if we can do some maybe validation of the HRRR smoke model, the high resolution rapid refresh smoke model, where right now we're consuming 2 data types. One is vertically integrated smoke, and the other one is near surface smoke. And one of the things that we're very interested in is how can we take surface air quality measurements and the HRRR smoke model and give decision makers better information for what kind of equipment responders should need in these areas, given the measurements and predictions, and also to alert communities for smoke. I'm not sure what kind of air quality alerts you might issue, but just to kind of work together to do that sort of effort. Is that relevant?
Yeah, Dave, that is extraordinarily relevant. So, like everybody in California, Los Angeles is plagued by wildfires, and so we have a variety of interesting firecast, kind of trying to do very short term, like in the next day or 2, fire forecasting. But we would love to do that, and our fire department is really quite forward facing in technology and data.
Oh, great. Awesome. So is there a good way, Jeannie, I think I've tried to send you a couple of emails in the past, and I think they might not have gotten through, or it's just COVID took over everybody's life. Maybe we can connect again, or I can get.
Yep, I just dropped my email in the chat too.
Awesome. Okay, that sounds great. Thanks.
Great. Thank you, Dave.
All right. We might have time for one more question, if anybody's got anything.
Good morning. This is from Chonglin Xie at NASA Goddard. Can I have one more question?
Okay.
Yes. Okay. Thank you. Yeah, very good presentation especially about this machine learning. I believe hourly data for a year should be good enough, but I'm not sure if you also would consider about the seasonal structures of your predictions. because of 1 year probably only include one of each seasons. So perhaps in the future, you may kind of include a couple more years. That would be probably cover a more seasonal change. And also even probably can consider kind of partition them to different seasons to do analysis. Maybe spring, summer, they will be different. And also look at like you also currently you study the PM 2.5 and NO2, and all the features could be different. So perhaps even okay, you can consider to kind of target different variables for different, from different approach. Anyway, this is my comment.
Yeah, thank you very much for your comment. Yeah, you are right. Using only 1 year data, the algorithm will not learn the seasonal pattern. It will learn the pattern within a week. For example, in weekends, the air pollution is less, but to be able to learn the seasonal pattern right, we need more data, at least a couple of years of data.
Great, thank you. It's already very good practice here. I'm kind of amazed you already can do especially you do the, of course, the validation is very important. You look at that, you already got very good outcomes. Thank you.
Thank you very much.
Right. Thanks so much, Jean and Mohammed. That was great. Our next speaker is Karen Moe from the town of Cheverly, Maryland, talking about a community data project there. Welcome, Karen. You're up.
Thank you, Beth. Let's see. Okay, as that's coming up, the town of Cheverly is a town of about 6,000 households. We're about 3 miles from the District of Columbia, Washington, D.C. And I'm not quite seeing the slides yet.
Yeah, but it looks like, Mike, the sharing stopped.
Just a second ago.
Yeah, wondering if we lost Mike. Mike, you're muted if you're talking.
Yeah, the slides came up for a second and then they went away again.
Karen, do you happen to have the slides on your desktop?
I do.
Could you click that green share screen?
Green share. Let's see, live. I don't see green.
So if you're looking at the window, it's at the bottom, like right in the middle at the bottom. Yep.
Yeah. And then I can share.
Perfect.
And that's
great
me.
job. Okay. Yep, we can see it. Thanks.
All right. And I guess I have to get into my program to, 1 second. I'm going to go ahead and pull up my copy of it so I can. Is that still looking good?
Yep, it still looks great.
All right, let's get started then. So a small town outside of a big metropolitan area, Washington, D.C. And this project is one that we're doing a small grant in the neighborhood of $50,000 went to the University of Maryland School of Public Health, and Jan Archer is with us today. This was the description. So this is very much a project from a kind of citizen science point of view. And this is a description of our problem statement where we have town officials are asked to evaluate what's happening in the neighborhood, especially when an industrial partner wants to get an air quality permit or waiver. And so I'm going to basically go through this problem step by step. Here I show the town of Cheverly. We have a a metro station here. And this is the
Karen,
zoning map. And you can see the gray area where we've got dark gray is heavy industrial and light gray is light industrial. The pink stuff is probably going to be changed to industrial. Yellow is the town. This is, I live here in this town. There's streams going through here, and basically the town does not have good quality air quality information. When they get a request from an industry, say a junkyard that is recycling metal, the data that exists from the Maryland Department of the Environment is between 9 and 20 miles away. They're in more rural areas outside of the Washington Beltway. Turns out Washington, D.C. has a couple of monitors that are near the Anacostia River, which is just off of the screen here. And that's all that we've got. So we are working with Dr. Jacoby Wilson at the University of Maryland's Institute for Applied and Environmental Health. And there's a link in my charts.
Karen,
yes.
can I just interrupt you for 1 second? It turns out Mike is actually the one projecting right now. So if you will tell him when to advance, then we won't get a disconnect.
Oh, thank you. Yeah, because I was looking at my charts. Thank you. Yeah. Okay, so we have worked with the University of Maryland. They have what they're calling a hyperlocal air monitoring network. And at the bottom of this slide is a link to their Dr. Jacoby's site. The goals of the project are basically helping our town. We got to understand what are our pollution levels, what is the baseline. We don't have that information. Before these requested changes might take place. We want to educate our residents so they can understand the quality of their of the air in our neighborhood, inform our decision makers, and look to mitigation efforts. So let me go on to the next slide. Oh, the project involves these commercial off-the-shelf sensors, Purple Air, and we have two little more sophisticated air qual microsystems. They're about the size, smaller than a shoebox. And I provide some of the basic data that is being monitored. The Purple Air is primarily a PM 2.5 and links to these sensors. So it's all off-the-shelf sensors. Next. So we have some 20 Purple Air. These are our proposed sites, and we've actually implemented now 3 sites. The kind of dark blue sites there are the Purple Air. The green sites are future ones that we'll do in our phase 2. The purple one up by Town Park, and there's another one clustered with some, those are our 2 Aeroqual monitoring systems. And then in these little black markers, I show there's 2 junkyards, recycling plants. We have a concrete batch facility. And there's also a proposed distribution center, which is going to have some 20 long line trucks coming in daily and over 400 vans leaving this area and distributing packages. So a lot of pretty heavy industry. Next, and that's, yeah. This was last week. We implemented a Purple Air. Jan is there with my colleague in our Green Infrastructure Committee in the town. And up on the ladder, Ngozi is with a local high school. She's a rising senior and is being mentored with Dr. Sakobi's Wilson's program. And I just have a snapshot of the Purple Air data that's for one of our sites near the Chevrolet Pool. Next slide. And there's our Chevrolet Pool location. This is my final side, but we are very involved with reaching out to our students both in Chevrolet and nearby the University of Maryland. But we want to get them involved in informing the public, in putting information up on a website, providing signage here at the pool, at the park, which was the previous picture. And eventually we'll have some programs with the University of Maryland with some mobile air quality units so that residents can really get an appreciation for what's happening as they walk around their neighborhoods. So our approach then and where we are next is with the software. In fact, I'm really looking forward to making some connections at USIP with people who might have existing tools, especially focused on Purple Air, and being able to ingest both Purple Air and other commercial sensors so that we can develop more detailed information, not just about the current values, but have a baseline and a historical record, and that we can really start identifying some of the trends and providing our decision makers with higher quality information that helps them answer their questions when they're responding to the state of Maryland regarding industry requests for environmental waivers and the like. So I think this is my last chart. Maybe I'll stop here. Jan is joining us today, and if we have any questions, if there's time, take some questions.
Hey, Karen, this is Yan. I just want to say great job. And then just to tag on a piece to the end there, we're definitely looking for collaborators in terms of, collaborators, but also kind of case studies and examples of moving this data to action. As you were mentioning, Karen, and then just like similar to, we've talked with some folks at OpenAQ, so it was cool to see the previous presentation. About like a unified data platform for these networks that are including data from different sensors.
And ideally, once we have our ground sensor data organized and producing information, I'm intrigued with the idea possibly collaborating with Gene Holmes group in LA and looking at ways of integrating in satellite data that they are testing and finding useful in the city of LA.
That would be great. All right. Thank you so much, Karen. That's really interesting. I have tons of questions for you, but I'll hold them for later. Because I think we need to keep moving. So our next speaker is Randall Martin from Washington University in St. Louis. Randall, are you there?
I am, thank you. And thank you for the opportunity to speak with you today. So I'm coming at this from both a data consumer and data user standpoint. And we'll focus on progressing from global to urban scales. And this work is motivated by the immense concerns associated with outdoor air quality, with millions of premature deaths associated with it each year. On the next slide, please. As well as the vast areas around the world with grossly inadequate ground-based monitoring for exposure assessment. So that slide didn't come up appropriately, but what you should see is a global scale map that shows the density of ground-based monitoring. And it should show that most countries in the world have no operational PM2.5 monitoring at all. And you might sometimes hear in the media about people studying the most polluted city in the world, but given the gaps in ground-based monitoring, it is quite likely that city is unmonitored. To meet even a basic goal of 1 monitor per million inhabitants would require thousands of new monitors with immense cost and logistical challenges. And so that motivates alternative measures of PM2.5, which on the next slide are apparent from, oh, that one didn't come up either. From both satellite remote sensing and modeling.
Excuse me, let me interrupt for a second. I've got the slides here in PowerPoint. Why don't I take over sharing right now so that they don't, it didn't translate well, the upload to Google, I think. So if you'd like, Mike, I'll take over the screen sharing so that Randall's slides don't look so weird.
Thank you, that sounds perfect.
Yeah. Okay. All right, go ahead.
Great, thank you. So this is showing you the map, and it should be clear that the gaps in ground-based monitoring. And the next slide shows information sources we have to contribute to air quality assessment at the global scale, both from satellite remote sensing as well as from modeling. And all of these instruments and algorithms have strengths and weaknesses that vary with location and vary with time. So an overarching theme of our effort is to evaluate the quality of these different data sets versus the ground-based sun photometer network of AeroNet that accurately measures aerosol optical depth from the ground. And this enables assessment of the time and space varying errors of the different data sets and production of an overall best estimate that inversely weights by the relative errors. About 80% of that information is coming from satellite remote sensing and about 20% from a chemical transport model that I'll speak about more momentarily, where satellites have challenges over either clouds or snow. But we're still left with the challenge this represents a columnar integrated optical quantity. So on the next slide, which then motivates the application of a chemical transport model to calculate that time and space varying relationship between AOD and PM2.5. And there should be an animation here. I don't know if you're able to trigger that. Yes, I saw a play button. That
figure it out.
Yeah, so, and purpose of showing this animation is to emphasize both the global scale nature of this air quality, as well as the time and space varying relationship. You're seeing yellow corresponding to mineral dust coming off of the major deserts, blue for sea spray at high southern latitudes during this month of July, green for organics, largely from fires, also from biogenic sources, black for black carbon or soot, and red for the sulfate nitrate ammonium system. And given the time and space variability of this system, we'll apply this model to calculate the time and space varying relationship between AOD and PM2.5, coincidentally sampling with every individual satellite and retrieval. And on the next slide shows the result of the completion of those two major activities. And first, at the global scale, on the top, the numbers on the color scale are striking. They vary from less than 10 micrograms per cubic meter over parts of the Americas, where we do have concerns about air quality. And then they extend out to more than 100 micrograms per cubic meter over densely populated areas. by providing a global observationally based information source, it's proving a valuable resource for a large number of international assessments that you see on the bottom left. And even though it's at the global scale, it's providing information that is progressing toward the urban scale. And you can see that down in the bottom right. But the key limiting factor in the quality of the urban scale assessment is the ability of a model, global scale model, to represent this local urban scale information. And so that motivates the next slide, which describes the NASA AIST project that I'm leading to connect the modeling activities from the global to the urban scale. And there's a lot of technical aspects here, but it's really summarized in 3 primary activities. The first involves developing connections with NASA GMAO through their Earth System Modeling Framework interface known as MAPLE, and connecting that with GeosChem. The second is to develop the performance, portability, and parallelizability of this high performance version of GeosChem through updating the software build system, a package manager, developing a multi-node cloud capability, and through software containers. And the third component involves closely integrating with the CubeSphere meteorological archive being generated by NASA GMAO to facilitate an accurate representation of their meteorological simulation. And at the bottom, you're seeing some additional technologies that are included as part of this activity. And this is, as I've already alluded to, connected with NASA GMAO as well as with colleagues at Harvard and at MIT. You can see their slides are down at the bottom, or their images. So the next slide gives an example of an application that's being developed as part of this project. And it's involving a stretched grid capability to enable nimble focus at very fine resolution over an arbitrary domain of interest. One can specify this at runtime. There's no prior preparation necessary to identify this domain. And it allows for a focused simulation at fine resolution over that domain, while sustaining the global scale capability, which is important for representing long-range transport. So the next slide then summarizes some of the opportunities and needs for connecting from global to urban scale, and the role for advanced modeling and high-end computing. The charge that I read that we were tasked with was to identify some of the technological aspects of these challenges. And our main challenges are quite similar to other high-end computing, involving access to sufficient computing, sufficient storage, and I/O and bandwidth. But some of the more specific technology needs are listed at the bottom. They include continuing to develop and connect with the Earth System Modeling Framework interface being developed at NASA GMAO, known as MAPLE. Developing familiarity with some sophisticated tools for disseminating and sharing high-end computing platforms, such as package managers, build systems, and containers. And developing the familiarity with a CubeSphere meteorological archive that has some subtle differences with respect to a traditional lat-long grid. So with that, I'd like to thank you for your attention.
Do we have any time for a question?
Yeah, let's see, 10:05. We could probably take one question. Let's do it. Any questions?
Hi, this is Dave Jones. I have one, so I'm just trying to see where to position this on the awesome meter. It's pretty high up there. I'm just wondering, as you look at different urban areas, how scalable is the model? In other words, you can focus in on a certain area. Is there a limitation for the number of urban areas you can scale, or is that a direct relation to the amount of computational resources that you need just to make that happen? And the second part of that question is, do you have any output that might be accessible in like a web services format, so we can get this into GeoCollaborate and combine it with other data sources and do some fun stuff? Thanks.
Yeah, thank you for your interest. And the development of the stretch grid at this stage is focusing on solely a single domain that will be specified. So one could specify a city or location, a region at one time, and then conduct a separate simulation if one wants to examine another domain of interest. And thank you for your interest in web sharing. This activity is still very much in development. We're really 6 months into our 2-year project, and it's at a stage of testing and demonstration, but it will take, I'd say, another, let's say, 6 to 12 months before we're probably able to share it more widely. There's a lot of effort that goes into this development.
No, that's great. That's great job on this. And when you get to the point of wanting to make the data even within ESIP or within a small group available, that we might be able to combine it with other data sets like satellite imagery and things like that, I'd love to maybe be one of your early adopter, beta tester, alpha tester people.
Terrific. Thank you so much.
Right. Thank you so much, Randall. Super interesting stuff. Our next speaker is Jennifer Way of the NASA Goddard DAC, Distributed Active Something Data Center. So Jennifer, are you there?
Hi, yes. Beth, you can make it as a presenter mode. I think you should be able to, so everybody can see more clear. There we go. Cross that out. All right. Thank you for having me. We are the Goddard Data Center, Earth Science Information Data Services Center, JESDISC per se. And data is the butter and bread to the data center, especially to our data center. So today I want to talk about how we as a data center perspective to enhance the data usability, especially to air quality researchers through our services and tools. Next slide, please. Previous one. Thank you. So I want to spend a little bit of time talking about the pain points for our air quality researchers. So I basically just highlight a few of high-level points from my perspective, due to the experience that I have at the data center interacting with users and providers. So I group them into 3 areas: from data side or user side, or even from the data center side. So on the data side, there are multiple flavors of the data depending on the data latency. There's something called real-time data, near real-time data, and research products. Do you know the differences among them? And the data quality among them is somewhat a little bit different. And what about the observational type data? There are in situ data measurements that we have heard from the previous speakers. And also the model data. I think Randall mentioned about using the model to assimilate the PM 2.5. And a lot of remote sensing data, especially from the satellite. data, the information content from all these different types of the data are somewhat different. And not to mention, we have 4 different satellite processing levels. They're slightly different or for their information. And sometimes the processing, there are multiple algorithms for retrieving the same physical parameters. And they're different. And to make it worse, and the data are scattered around, it's impossible to find in one place. Do you know really which data sets that you need? And you may say, most of you are the data experts here. You may say, I know exactly what I want. And as you can see on the right-hand side, I put a very a simple schematic on the user's knowledge in terms of the air quality data. And you all, as an expert on this chart, is towards the right. But the needs for the data varies. So you may need a little bit data, or you need a large amount of data to for your own purpose. But to some people with little knowledge on this science knowledge, as Karen alluded, that the science-minded scientist public, and they trying to get access to the data. They are totally lost what kind of data they can use, what kind of data they're looking for, not to mention what kind of services they can utilize to make their life a lot easier. So especially on the data center side, and due to the broad spectrum of this user science knowledge, so it is very difficult to satisfy our users' needs. We do not really want to customize our services to fit individual needs. Not to mention, currently we do not have a standardized metadata model. Until recently, you might have heard something called CMR, Common Metadata Repository, to start with the collection of metadata standards. But what about variables? What about the services that implementing on these data sets? Because air quality data are scattered among various stacks with different tools and data formats. This caused a lot of hurdles to users. I actually put extra slides in at the end, but I'm not going to talk about it. That what air quality indicator variables from EPA has or measure, and what currently NASA data can support, and what exactly adjusts this we have in our holdings at the end of our the slides. But I'm not going to talk about it in the interest of time. So recognize this pain points. I want to talk about some of the services that we recently implemented amid this pandemic, and what are the lessons we have learned through this difficult time. What additional value-added services, especially some of the people mentioned earlier in the GIS support that we provided to users. Next slide, please. So COVID actually has caused a lot of impact on all of us. We have seen more data demand from our distribution metrics during last couple of months. As we try to develop some services to enhance our data usage, we have learned from the user side that they have required to use the GeoTIFF or cloud optimized GeoTIFF, so-called COG data formats, so that they can plug into on the GIS interoperable tools such as QGIS or ArcGIS. And we have heard the community would like to prefer a one simple composite interface, such as dashboard, as you may have heard. And actually, a couple of weeks ago, NASA along with JAXA and ESA, just revealed this dashboard, Earth observation dashboard, that we are fortunately to put our contribution to this dashboard. And as a user side, they would like to have the data with higher spatial resolution and preferably with a longer time period. So allowing them to intercompare on the instance or on the data, along data records. However, on the data center side, that we have been asked by our data producers and scientists to facilitate the data by adding quality control services, such as peak out, which is the best algorithm for specific parameters. We need to filter out bad pixels due to the cloud contamination in the satellite footprints. And especially when users are looking at to do some trend analysis over a specific region. Since the technology has been involved, we would like to implement a scalable visualization, not to cater for a specific region, but have a global coverage when people want to compare different regions. And as we know, when any events happens, the impact sometimes is longer than we anticipated. So we really want to provide both instantaneous or a long time data records in a map or time series that give users better pictures for a specific event, such as COVID, as we all in right now. And we all researchers, how can we learn from each other? We wrote papers for specific data uses, for using specific data and analyze them. So how can we leverage the knowledge from these published papers to enhance data usability? Next slide, please. So knowing, previous one, thank you. So knowing what user would like to get and what is a data center would like to implement in the beginning of the COVID timeframes, we started a story map that simply wanted to enhance users' understanding of using and interpreting OMI and O2 data. In this story map, we just want to demonstrate simply to look at the changes in the observed tropospheric NO2 column density over China before and after the lockdown due to COVID-19. So in this story, that we use OMI NO2 level 3 data to give you a daily snapshot of NO2 observation in a map and time series from December 1st last year all the way till March 20th this year, shown on the left-hand side of this diagram. We also provide 10 years average from the same instrument observation, OMI and O2, allowing you visually intercompare the differences on this time period with the 10 years before the event happened, which show on the right-hand side. And in this story, we also provide a lot of cautionary notes on how to interpret this data. And you can follow the hyperlink of this title to link to the story, which I'm not going to go into the detail. The next slide, please. So as I mentioned earlier, users prefer to have a simple interface, allowing them to access and visualize the data on the same screen. And I mentioned earlier, NASA so Beth, you can refresh your screen that I already granted you the privilege.
Oh, great. Okay. Thank you. Sorry, Jennifer.
It's okay. We're on slide 5. All right. Previous one, please. Thank you. So basically, we create this ArcGIS web application for interactive map viewers with a lot of features or simplified features behind it that allowing you to have a global coverage for users, and also allowing you to zoom in and zoom out and pan over for different regions. And you can compare up to 2 layers to view, and we link to the data source. And we can also easily adopt or link to other published ArcGIS layers for users to intercompare. And currently, we added the layers from Mera to Aerosol optical depth, and providing the same month or Mera data for the past 10 years. And we also we also added the OMI NO2 as well as ozone. But also, since the event, like I mentioned, it will impact on other parameters. So we pre-calculated air's temperature anomaly and a precipitation anomaly from the GPM iMerge. So we uploaded layers there. But the point here is we can add more GIS interoperable layers, allowing user to come in and see that, be able to intercompare, and then also point it to the data source. So the user will be able to reproduce the same results for themselves. Next slide, please. So yesterday, actually, from the ESIP, we have heard a lot of cloud-related presentations. It seems the cloud-optimized GeoTIFF has become one of the most popular data formats in the cloud environment, as well as in the GIS world. So I really want to—
Jennifer,
yes.
I'm sorry to interrupt, but can you sort of wrap it up in the next minute or so?
Sure, I'm almost done. So basically, this is on-the-fly services allowing user, before they download the data, you can subset and remap to different grading schemas, such as ECMWF, Mera2, or GFS, just to mention a couple. And you can get it to a specific data format. You can drag and drop into any GIS tools. So next slide, please. So this will be my last slide. I just want to tell people we currently implement on the GIS application for level 2, especially for OMI and triple OMI. But I want to give a shout out. We actually have a prototype presentation utilizing the publication knowledge on the data. Further detail, I will refer to the Friday research showcase on Irina's poster. Thank you. So I can wrap it up right now.
Awesome. Thank you so much, Jennifer. Really interesting stuff you guys are doing. We are getting behind, and I think we may want to just move on to the next presentation. So if there are questions for Jennifer, we'll defer those to later. So let me introduce our next speaker. Danielle Gronin is with the NASA Atmospheric Science Data Center, DAC, and she's going to talk to us about some tools and services available there for air quality data. And Danielle, are you there?
Yes. Can you hear me?
Yes, we can. And I'm trying to grab your slides real fast. Sorry.
No problem. Hello, everyone. Like Beth said, my name is Danielle Gronin, and I work at the Atmospheric Science Data Center at NASA Langley, which is located in Hampton, Virginia. I was hired about a year ago in August, and am on the science outreach team, which I'll talk about a little bit later.
Okay.
Great.
All right. Sorry, Danielle, go ahead.
No problem. So I am the science lead at the ASTC. So I have a background in physics and meteorology, atmospheric science. So I hope to provide some science expertise to the data. We have a lot of cool things going on. We like to kind of advertise our satellite data for monitoring the health of the Earth. You can see some little facts about the ASTC in the center graphic. And we have on the right a graphic from our Earth data webinar we did focusing on Australian wildfires and our air quality. So I want to talk today about some of the data sets that we have and some of the tools we have at the ASDC, which is a nice follow-on to what Jennifer talked about. Next slide, please. So we have a lot of cool air quality data sets. Air quality obviously is a hot topic, and wanted to just kind of showcase some of our data sets for public use. So we have a lot of aerosol data sets such as Miser. We have a curtain or profile product called Calypso, which is very popular, especially for things like volcanic eruptions or dust plumes or the Australian dust bushfires. And we also have several airborne or suborbital campaigns, and I listed a few there. Another one of our areas of expertise besides aerosols is tropospheric composition or trace gases. So we have MOPIT, which is a popular data set which studies carbon monoxide, and we have TESS, which studies ozone, and then we have some more airborne campaigns. I will talk a little bit about the ArcGIS image service that we now have Miser and MOPIT on in a second. For the stratosphere, we have the SAGE-3 instrument, which was on the outside of the International Space Station, which looks at several things such as ozone, water vapor, nitrogen dioxide, etc. And then we have two very exciting missions coming up in 2022. You already heard earlier from Jean Holmes about Maya. So we are the official DAC of record for Maya. We will be receiving their data and distributing it. And we also are the DAC of record for Tempo, which is very exciting. That will be providing ozone and nitrogen dioxide on a hourly scale. So those are some of our air quality data sets. Next slide, please. So to kind of piggyback on what Jennifer said, she said that, you know, a lot of users want ArcGIS geospatial friendly data. So we just recently set up a new ASDC ArcGIS Enterprise or portal where we are serving out these data sets that are already a little bit more analysis ready, if you will. So we have a couple subsets of Miser, aerosol optical depth, MOPIT carbon monoxide, and then Ceres, which is a radiation product, which is being used in a power application. But you can see what the portal looks like on the lower left. And when users click on that, what pops up is on the lower right. So you can see the swaths of the MOPIT data, and you can toggle different times. We don't have full time range of the instrument yet. We have, I think, about 3 years. But this is a work in progress, and we're really excited to do some cool new things with this. Next slide, please. So when I was hired about a year ago, this new science outreach team was formed at the ASCC, and really the goal is to do more of the outreach and more of the translation between the data providers and the data users. So we do a lot of different things. We attend conferences like this one and kind of advertise our services and tools. We also attend science team meetings and talk to the data providers and get feedback from scientists and general public, and try and provide some cool tools for bringing more people to the data. So our goals are to improve data access and usability, develop tools for data use. We provide support for the mission science teams. We're working on a lot of the new missions right now, Clario Pathfinder, Pre-Fire, Maya and Tempo, and working a lot with the standards and the documentation for that. So I really do think we are what I like to call the translators between that technical NASA jargon that a lot of non-NASA people don't understand to kind of make it more accessible. Next slide, please. And some examples of our tools and services. So our goals really are to inspire, communicate, and showcase NASA Langley science. And our stakeholders, we work with a lot of universities and with JPL and other NASA DACs. We're producing micro articles. We've got a Jupyter notebook related to the Australian bushfire. We've got several ArcGIS story maps, including one on the intro to Maya and Tempo, which will be released later. And we also did a data-driven storytelling webinar that is available on YouTube. So next slide. That's it from me. Just wanted to showcase some of the air quality data sets and that we have at the ASCC. You can check out our website here. Feel free to email me, and thank you for your time.
Great. Thank you so much, Danielle. That is really awesome. Yeah, so we've got, lots of data users out there needing air quality data, and we've got some really great resources at Goddard and also at the ASDC. Hopefully that gives people an idea of who to reach out to and, where to go if they need any help. Danielle can certainly direct you at the ASDC, and Jennifer can help you out at Goddard. And thanks so much to all of our speakers. We are running a little bit late, so I think maybe we'll skip the breakout. Well, we've got 15 minutes. So
Beth, there are two questions in the chat too. One for Danielle, and it looks like one coming back to Karen. And I think you could skip the breakouts or not. That's entirely up to you guys.
Yeah. Okay. Let's take I think we'll skip the breakouts and we'll just use the last 15 minutes for people to ask questions of the speakers that we had to defer, and maybe have a group discussion. Mike, are you okay with that? Or do people really want to do a breakout? I'm just afraid, by the time we all get into separate rooms and try to talk, we'll just have to come right back again. So I'm kind of reluctant at this point to do it, because we really are down to just 10 minutes here.
Yeah, so
go ahead, Mike.
The only other thing that we need to do is the 3 takeaways.
Okay, great. So we've got a question in the chat. Emphasis of last 2 presentations has been on interactive services. Are there parallel efforts to improve client-side software toolkits and APIs? Jennifer, Danielle, do you want to just give us a response?
Yes, actually, I just responded in the chat box that we are at just this side that we are providing the API for our services. I just didn't put emphasis today in my presentation, but we do have the API for some of the services, allowing user to subset or when they want to validate in situ data sets.
And I just want to add to that it's been quite tricky for NASA IT security to put out Jupyter notebooks and put out software. We have pretty strict IT rules. So we are working on an API for our future SOOT tool, our suborbital order tool, And we are trying to work on, I think there's an API for the power project that uses series data, but it's a bit trickier to get out that software and Jupyter Notebooks code, for example. So that's a problem we've come up with. And it's hard. We're trying to communicate more with the other data centers, but it's been a bit of a work in progress. So I just wanted to add that.
All right, thanks, Jennifer. Thanks, Danielle. Thanks for that question. Are there other questions? It looks like there's a little conversation here. Karen, do you want to bring this to take this up with the group, tools for data analysis? Do you want to talk a little bit about that? You and Chung Ling are having a little conversation in chat about that. Is there?
Yes.
Yeah.
That is one area that the end of the presentation, I said, we were really looking for software handouts. And I think Jennifer's talk, and I also saw a note that the NASA Globe program might have some relevant tools for us. So that's kind of our next step, is once we get a lot of these sensors up and running, is integrating that data. And I really liked what Jennifer said about doing the analysis for the right community. And our community is those decision makers at a municipal level. Jan, I don't know if you want to add to that.
Yes. Thanks everyone for the really fantastic presentations. So one of the questions was with regard to the validation and filtering of the data that's going out, and particularly as at the final stage of communicating to the public. So we're working toward developing a dashboard that could help with that translation to the appropriate translations for the appropriate audiences. We're not there yet, but yeah, and like Karen mentioned in the comments, we're looking at existing tools to see how we can synergize and collaborate with these calibration tools that exist in terms of getting the information out in a way that's useful to community members.
Yes, thanks Yan and Karen and this Xiaoming. Yes, that's exactly the reason I'm asking. Yeah, because this citizen science data is very important. Actually, it can be complementary to the conventional data set, but at the same time, there's always double-edged sword here. So how do we control this data quality? That's also be an issue. Thank you both your answers. Thank you.
Absolutely, thanks for the question.
All right. Do we have? Let's see. What else do we have going on in the chat?
So there's a question from Lee about any of the air quality data at the global level have dust, sand deposition, and chloride deposition, or models to calculate those parameters?
So actually, MERA 2 data I mentioned in my presentation has a aerosol components part. So they actually, based on the model run, which is the gold car model, they have attributed to 4 different groups of the aerosol types. So maybe you can take a look at it, the MERA data. We have the MERA data aerosol from 1980 all the way to recent.
All right. Thanks, Jennifer. All right.
This
any
is Dave.
Questions? Yeah, go ahead, Dave.
I just have one thing. I was thinking a lot about the discussion of the dashboards, because we work a lot with emergency managers and utility crews and a bunch of other folks in the transportation industry. And there are a lot of organizations that are coming up with dashboards. As a matter of fact, there's been an explosion since COVID of agencies and organizations setting up dashboards. And my recommendation would be that if you set up a dashboard, to set it up in the context of use cases that highlight your data. So as opposed to saying, everybody come to our dashboard to look at all of this information, because there's no one-stop shop. And so if you can think about setting up a dashboard as a use case, or perhaps maybe using the story maps or whatever, but just highlighting your data in a use case, that will really help. And then if you have the links to the actual services that you're providing, then people can pull that down immediately right into their systems.
Yeah, thanks, Dave. Good point. Okay, so we've got about 5 more minutes, guys, and I think we wanted to try to end with just a quick, thinking about what the takeaways from this session are. I mean, I have some thoughts, so I'll just throw this out. It sounds to me like, we've got, this is a great opportunity for us to start a dialogue between the data providers and data consumers. And it sounds like the DACs themselves, the science team at the ASDC, people like Jennifer at the Goddard DAC are in a great position to sort of play this role of intermediary. So I hope that people, maybe one of the takeaways here is that the NASA DACs can actually be a real valuable player here in kind of bringing the scientists that are out there gathering data together with the scientists that are out there consuming and studying that data and trying to do some things with the data. So I'll put that one out there, and I'd love to hear from others what your thoughts are here as to, maybe what we should take away from this session and think about going forward in the future. What do we want to do? Anybody have anything they want to, any comments?
Beth, this is Karen Moe, and I put it in the chat, but I really think an important takeaway is to look at the products that are coming out and producing a level of information that's targeted for the certain communities, whether they be research scientists or decision makers or the public, and really consider that as an important output from any air quality monitoring system.
Yeah, for sure. Thank you, Karen. So, and we've got a comment in the chat box, a potential takeaway that there's a broad interest in fusing in situ data. Oh, this thing keeps jumping and then I lose my spot, sorry. Fusing in situ data with remotely sensed data and models to improve awareness of both current conditions and predicted conditions. Yeah, that's from Steve Young. Do you want to say anything more about that, Steve?
Sure. I should have said model outputs, I think, but this came up a little bit in a presentation on envirosensing yesterday, and I think I heard from Karen on that, but that seems to be kind of an underlying theme that I was hearing a lot today, that we'd like to take all these rich sources of data and continue. I mean, I think there's a lot of progress. Like, it was pretty cool what Jean spoke about in the opening session, but continue to make progress in fusing these things together to, especially to support decision making.
Right. Yeah, for sure. Yes, and I think that actually segues nicely into the next comment from Ethan McMahon of the EPA. It'd be great to understand what the cities and communities need to affect policy change. So this is a question that I find really interesting as well. You know, we don't want to just send them an .cdf file, right, of data. they're like, oh, what is this? So what do they need? Maps? So Ethan's asking, do they need maps or a certification that the data they show is accurate, or the number of people who are adversely impacted? And I think Jean had to leave. Karen, you may be our last representative here in that space, but it would be really interesting, I think, to understand, you know, sort of how data should be used to start affecting policy more effectively. Do you have any last thoughts on that, Karen?
Actually, I was about to respond to Ethan saying yes, yes, and yes. The certification would be needed if it gets to a level of a legal pursuit. So, you know, if a company, you know, wants to get a waiver for air quality requirements, they're going to demand that the information be certified. But in general, I think that the need for maps, things you know, tied visually to the location is probably a baseline that would be needed for all of the community members I'm dealing with.
Right. Well, let me just say we're out of time, but these questions and more can be discussed further at the ESIP Air Quality Cluster meetings, which happen on, I think it's the 4th Thursday. Mike, help me out here. I'm having a brain glitch, and I think we're on the 4th Thursday, but anyway, thank you all so much for attending today. It's great to have you. Thank you to our speakers, and I hope you'll all consider joining us on whichever Thursday it is for our—
It is the fourth Thursday.
Thursday, okay, for our regular air quality cluster meetings with ESIP, because these are precisely the kinds of questions we're going to try to address there. So thanks again, everyone, for coming. Thank you to the speakers. You guys were awesome. And yeah, yay, good job. All right.
Nice work, everybody.
Bye-bye.
Bye-bye, thank you.